Hello everyone, this is my fourth video of research article which are based on IoT enabled devices. I hope you liked my research article number 1 well. I have shared previously 3 videos of research article 1. Now coming back to the research article number 2 which is related to IoT enabled smart agriculture. In smart agriculture system we use microcontrollers, and in this research article we use a very significantly used microcontroller which is Raspberry Pi. We can use Arduino Nano, but here we will use Raspberry Pi whose efficiency is much higher as compared to Arduino systems. So how the idea of this research article was taken, I will explain you in this video. The abstract: unpredictable weather patterns and a lack of timely accurate information in Uganda, a country where the weather patterns were unpredictable and the lack of timely means they are not getting the information on timely basis whenever they want, so it would be difficult for them to check the weather patterns. And accurate information, they were not able to get the accurate information of the weather patterns and the challenge farmers in Uganda. So they were facing very deep challenges in Uganda, and the farmers were not able to predict the weather patterns there, so it would be difficult for them to maintain and to save their crop. So it will lead to the poor crop management ultimately, and the crop yields will get reduced eventually, and heightened vulnerability to environmental stress means they were not able to produce their crops on time, and the crops were not of very higher yield, they were very less in amount. So this research presents a framework for IoT enabled smart agriculture. So in this smart agriculture system we will use microcontroller which is Raspberry Pi. Raspberry Pi is a very famous microcontroller. You can read it about Raspberry Pi on Google, and this technology provides the real-time monitoring of weather and environmental condition. Like from environment we can check the temperature, pressure, humidity, and we can manage our crop patterns well by real-time monitoring of weather and environmental conditions. But we can do it only with the help of IoT-enabled microcontroller which is Raspberry Pi. So this framework integrates sensors. We can use different kinds of sensors to calculate temperature, rainfall, how much centimeter rainfall is there, or there is rainfall or no rainfall in the future or at present. We will check soil moisture, we can check, and pressure. So we have to use different kinds of sensors. Like to calculate humidity and soil moisture we use DHT11 and DHT22 sensors, and we can use different kinds of sensors to calculate temperature, and they are connected through MCP3208 which is analog to digital converter. So this was the basic idea, how the idea to the farmers generated. They were not able to get the crop yields as they wanted, so researchers in that country, they developed a method which is based on IoT to make a system which is called a smart agriculture system. Smart agriculture system. Now coming back to the next point of the abstract, the data is displayed on an LCD screen. So the LCD screen was there in the IoT system, and data is displayed on that screen for immediate feedback. Means if there will be the changing environmental conditions, we can take a look back on the crop patterns, and the feedback is transmitted to the ThinkSpeak platform, or we can share the data to the cloud platform for centralized storage and analysis, and we can access the environmental conditions, the data through our mobile app or through web interface, or we can do cloud computing as well. So this farmers can leverage this framework to optimize, to maintain or to maximize their irrigation schedules. They can carry out the schedules properly and they can take a check back on the system and improve crop productivity. This method will improve the crop productivity in Uganda, and through actionable insights derived from real time and forecasted data on rainfall, and they can take a real time data, they can get a real time data on the rainfall, temperature, pressure and soil moisture. So these conditions are necessary. We use sensors, we need sensors, we need microcontrollers, we need an LCD screen, we need a web-based platform, ThinkSpeak platform to access the data, to share the data, and the researchers can innovate their IoT smart agriculture system very effectively. Next, additionally, the system incorporates predictive weather forecasting to dynamically control sensor activity. This system incorporates some kind of weather forecasting, means from the weather forecasting the sensors can control the activities, like we have yield, we want the yield of any of the crop. So if we use sensors there, we can take a check back on the crop yields on timely basis, and this will reduce energy consumption, this will reduce the manpower. We don't need laborers to go there to check the crop yield. Ultimately we can take a check back through our web platform and extending sensor lifespan. This will increase the crop yield and sensor lifespan. So simulated using Proteus, this proposed framework demonstrates significant potential to mitigate, to reduce the impacts of unpredictable weather. So we can't tell about the weather, next day there will be rainfall or some kind of sunny day is there. So in case of unpredictable weather, this method reduces the impacts of that unpredictable method by reducing water consumption. Water consumption will be less. If there will be humidity in the atmosphere, we can reduce the water consumption, improving forecasting accuracy, and this will ultimately improve the productivity of the crop. So this method, in according to me, this is a very productive method, and in India we can also use this method to improve our crop field. So in the next video I will explain you about the introduction of this research article, which is based on IoT, smart irrigation, smart agriculture system. So stay tuned to my YouTube channel. I will be back. Till then, take care. Have a nice day.